If you are using domain-driven design inside of your .NET applications, there are three concerns that you should be aware of when it comes to how you design your domain models. These concerns are domain model purity, domain model completeness, and performance. I'm going to explain what the three of these are and how they impact your domain model design. I first encountered this idea of purity, completeness, and performance in an article from Vladimir Khorikov, which I'm going to leave in the description of this video. Let me briefly explain what the three of these means. Domain model purity concerns with if your domain model references out-of-process dependencies. If it doesn't have any out-of-process dependencies, then we consider this a pure domain model. Domain model completeness deals with how much of the business logic is encapsulated within your domain model. If all of the business logic is inside of your domain models, then you've got what's called a complete domain model. If some of it is split between your domain model and application services, then you don't have a complete domain model. And performance, I think, is self-explanatory. It just cares about defining the most performant implementation. However, you will see how this forces us to either trade off purity or completeness. Now, if we draw an intersection of these three, so this will represent purity, this will represent completeness, and we've got another one for performance. The premise is that we can never have all three of them at once. So this intersection here is not attainable within your domain model. However, at any point in time, you can have two of these. So just let me copy these inside. So you can either have purity and completeness, or purity and performance, or completeness and performance, but you can have all three of them at the same time. Now let's look at a concrete example to understand why this is the case. I've got a use case for creating a to-do item inside of my application. And the domain model right now is anemic. It doesn't really have any logic inside, which is what we're going to fix. However, there is a new rule that we want to enforce with our domain model, and that is being able to have at most 5 or a configurable value of active high priority to-dos. Now, we classify this based on the priority enum, and high priority to-dos are either going to have a high or a top priority. So we want to somehow enforce this through our domain model, and we're going to view this through the lens of purity, completeness, and performance. Now I'm going to create a copy of our create to do command handler and implement the first version in there, and let's look at a pure and complete version. I'll also rename the file to match the type name, and we're going to leave the original untouched and implement our logic in here. So let's start by creating some sort of factory function inside of our domain model. So I'll create a static function that returns a to-do item. Let's call it create. And what do we want to do inside? We want to have this logic that we have here inside of our domain model. So I can just drop it here. Let's return the to-do item, and now we need to provide these values as arguments. So that's going to look something like this, and I'll need to just reference these when setting the to-do item properties. We'll update our use case to use our new factory function, and we'll get something like this. So now we push the logic down. We haven't completely encapsulated it because there's still a public constructor. We could fix this by creating a private parameterless constructor, for example, but I don't want to break existing code, so I'll just comment this out and leave a brief descriptive comment. But let's focus on our new business rule of enforcing a maximum amount of high priority to-dos. So remember that we want to make this pure and complete, which means that we can have external references inside of our domain model, but we also need to enforce our business rule within the domain model itself. So how we could enforce this is, for example, by accepting a read-only list of to-do items, and we're going to call this existing high priority to-dos. And what we want to do here is basically check that if the current priority is either high or let's say top, and the existing high priority to-dos, or rather the number of them, is greater than or equal to the maximum allowed number of high priority to-dos, then we want to return some sort of failure results. Now I have to refactor this to return a result object, and in this case we're going to return a result failure containing our to-do item, and we're going to say to-do item errors high priority limit reached. And now we've encapsulated this business rule inside of our domain, and we don't have external references, so this is both pure and complete. Now I have to somehow provide this list here to be able to satisfy our contract, and the simplest way to do this is a query like this using EF core, where we're going to fetch the to-do items for this user that aren't completed and have a priority of either high or top. And now I can pass these in to the create method. Now what we are sacrificing here is performance because we are loading all of the to-do items into memory. And this is kind of the worst case scenario. Imagine when there's a large number of to-do items that we have to validate. This wouldn't give us ideal performance in a production environment. So that's the pure and complete implementation. Now let's make another copy of this, which I'm going to go into and rename, and let's call this complete and performant. The idea here is that we get performance by not loading all of the entities into memory while still keeping completeness. So we have to delegate our business check to some sort of external service that's going to perform this validation for us. And I'm going to define this inside of our domain project in the to-dos folder, and I will call this abstraction a high priority to-do counter. So this is just an interface, but you can already guess that this introduces an external dependency. I'll create another version of the create method, which is going to have an additional argument being our high priority to do counter. So this is what makes our new implementation impure. And since this is an async method, we can even consider passing in a cancellation token. So what's going to change here is if the priority is high or top, we're going to get the count by calling the high priority to do counter, which exposes one method. We'll pass in the user ID and the cancellation token. I will have to make the entire thing asynchronous by returning a task. And then if the count is greater than or equal to the maximum number of high priority items, then we return a failure result. So now we have to use this inside of our application layer. So we go back to our use case. We'll inject this as another dependency, so high priority to do counter, and we're going to call this overload, which accepts a high priority to do counter and a cancellation token. We no longer have to load our high priority to dos into memory. Instead, we're just going to call our create method, which is now still complete because our domain logic is encapsulated within the domain model, but now it's impure because we are referencing an out-of-process dependency through the abstraction. However, we have significantly improved performance because we are only counting how many of these to-dos are there in the database. The implementation for this will be in the infrastructure project. For example, there could be a high priority to-do counter service, which implements our interface, and it does the same query, except it's now a count. And we also have to wire this up with dependency injection so that we can use it within our use case. So that's the second option. And let me give you the third option, and then we're going to discuss what would be the most optimal one. So I'll create another copy of this, and we're going to rename this to be pure and performant, but incomplete. I'll get rid of the high priority to do counter, and instead I'm going to move the logic of checking the number of high priority to dos into our application use case. That means I'll need another overload of the create method, which is going to be the simplest one that doesn't have any references to external services or anything like that. It just creates a to-do item and raises a domain event. So this is what we're going to be calling here. Let's get rid of the cancellation token and the to-do counter and the await. And now we've got our performance solution. We are only doing the minimal amount of work to check this additional business rule while keeping the domain pure, as it doesn't have out-of-process dependencies. Our business logic is now split within the use case and also any logic that might be enforced in the domain. And for the majority of applications out there, this will probably be the ideal solution because performance is something I don't want to trade off ever. So going the pure and complete route rarely makes sense for me in a production setting. And then depending on the situation, I could consider if I want to use an impure version and have most of the logic inside of the domain layer. But this only makes sense if the business logic itself is somewhat simple. Like this one check here, we'll probably be fine with this. It also improves testability because you can now test the complete use case only through the domain without having to touch the application layer. However, a lot of people are going to be uncomfortable with this as you are introducing additional dependencies into the domain model. So where most people land on is just doing their checks in the application use case. And once everything is said and done and we've made sure that we can run our domain logic, it's at that point that we delegate to the domain layer to do the remaining work. I know some of you are going to comment on the race condition here. There are ways to get around this, either with optimistic concurrency, by having a version that we checked on the database and retrying in case of a failure, or we could even completely fail the request. Or we could go for the pessimistic concurrency and introduce a strict lock for this use case so that whatever the result of this evaluation here for checking the number of high priority to-dos remains true by the time we get to call save changes, and we always keep a consistent state in the database. And having to deal with things like this is also what makes it difficult to keep the domain model pure. If we had to deal with database concerns and race conditions inside of the domain model, then that would really become a big mess really fast. However, keeping these concerns in the application layer allows us to keep our domain model simple. So that is how purity, completeness, and performance can impact how you design your domain models. Now, let me know in the comments which of these options you would choose. I always lean in favor of performance and then either pick and choose between also having purity and completeness, but I do this on a case-by-case basis and I don't really have a strict rule for what should be used when. Instead, all of these decisions should be made based on the current context within the application that you are building. If you want to grab the source code for this video and explore these examples for yourself, they're going to be available in the pinned comment right below. If you enjoyed this video, consider gently tapping the like button to let me know. Thanks a lot for watching, and until next time, stay awesome.